In this video tutorial, we will build a tree that is symmetrical as to its center node. We will build it in several variations. The first one is its left and right parts will have the node connectors point in opposite directions regarding the root node. We will first look at another way to build and arrange the diagram, with arrows flowing in just one direction, from left to right. There is also the possibility, by setting a single property, to hide the connector's head shape and make them straight lines. In this case, it doesn't really matter which of the two methods is used to arrange the diagram. We use MindFusion diagramming component for WinForms and apply the tree layout with various settings. We start by creating a new Visual Studio WinForms application in a directory called DoubleTree that we created earlier. In this directory, we have a folder called References, and there are 4 DLLs that we need for this project: the common and diagramming assemblies. Then we drag the diagram view icon from the toolbox and drop it onto the main form of the application. Note that the library automatically creates a diagram instance that is rendered inside this diagram view. The icons in the toolbox are from MindFusion WinForms pack, and the required references are added from there. We delete them and add the identical ones from our references folder. Now if we run the application, you will see that you can already draw diagram nodes, connect, and move them. Even with the little effort we've done so far, we have a working flowchart application. Since this is not what our application needs to do, we will go on writing some code. We declare a rectangle f variable called bounds, which will set the size of all newly created nodes. Its coordinates are of no importance because the layout algorithm will arrange the nodes anyway. We then declare a method called randomTree. In it, we will build the children of the node, provided as first arguments. As you might have guessed, this method will be called recursively. That's why we add the tree depth. It will show us when to stop. We first add a random number generator. Then we add inside the body of the randomTree method this code. We get the diagram that is the parent of the provided root node and check how many nodes it has. We want to make sure that at the beginning, the very first node will get at least 2 children. Then, we use the factory class of the diagram library to create nodes and links. If the direction of the tree is not reversed, we connect the root node with the children. Otherwise, we connect the children with the root. The good thing about the factory class is that it automatically adds the newly created diagram items to the diagram. Let's create now a root node using the factory class and call the randomTree method to generate 2 collections with random nodes, one for the left and the other for the right part of the tree. If we run the application, you will see a single node. Actually, these are all nodes piled on top of each other. This is so because they all have the same bounds, e.g. location. Let's arrange them with the tree layout. We add a reference to the diagramming namespace and a new method called arrange. There we create an instance of the tree layout. We call the arrange method of the layout and provide the diagram as a parameter. And that's all that we need in order to apply a layout. Now as you see, one of the tree branches is arranged well. The problem is we are not building a typical tree where the root node is at the top. Our root node is in the middle of the tree. We will add an argument to our method that tells it if we are arranging the left or the right part of the tree. If it is the left part, we have the direction from right to left. In the left part, the direction is opposite. We also need to set the reversed links property. Its value must be the same as the reversed parameter of the method. Now the tree looks well. Let's add some colors to the nodes. We declare two arrays with brush instances, one for each side of the tree. We fill them with solid brushes, whose color fades when the depth of the tree increases. We use the brush property of shape node and assign it to the subsequent brush from the brushes list or the reversed brushes list. Now our nodes are colored well with the root node being an exception. Let's color it with a gradient brush so it mixes the colors of the two brushes, from the left and from the right side. We will also call resize to fit items on the diagram, which will make it adjust its size so that all generated nodes could fit. We also call zoom to fit on the diagram view to make all nodes visible. The diagram looks really well now. We will add some styling to the arrowheads. We set their head shape to triangle, the brush to white, and the stroke to a shade of gray. The brush will fill the triangle, which we make 4 points large. The connectors look sophisticated now. What we'll do next is we will initialize two diagram item collections, which will store the nodes and links on the two sides of the tree. We call them left items and right items. We add the root node to each one of them. Then, when we create the nodes and the links, we add those from the reverse tree to the left items collection and the nodes and links from the right side to the right items collection. Note that now we need not have our arrows point in the direction of parent to node. All links connect the parent to the node. We must sort the two collections separately. We use the arrange override that takes as a second parameter a collection of items to sort. Now our tree is well arranged in both opposite directions. We can remove the triangle shape of the connectors when we set the head shape to null. This way it wouldn't really matter in which of the two ways you arrange the tree. And that's the end of this video tutorial. You can find a link to download the sample together with the libraries used in the video description. Thank you for watching, and thank you for your interest in MindFusion developer tools.